Today's Daily Dose of Math is about a task from the Math 4151 Algebraic Modeling course. When we look at this question, we might think it's from a science course though. I'm going to read the question to start with. A chemistry experiment happens in two stages. Starting at time 0, the first reaction causes a decrease in temperature, but after 6 seconds, the student adds a substance that ends that first reaction and starts the second reaction. Now the temperature starts to increase in a linear fashion. What will be the temperature after 24 seconds? Now, I don't have any room now because the question was so long to answer it, so I have to erase this. But the graph has all the information that we need so that we can proceed. Okay, let's get busy. The first part of the graph is a curve. We don't know for sure what type of function that is because the question didn't tell us what type it was. But they do give us points that are on that section of the curve, and that's plenty for us to do our tests to figure out what type of function it is. We won't do tests for the second reaction because it said in the question that it was linear. So we know it's a linear function. We can't work with the second reaction, the straight line equation, yet because we don't have enough information. Now, some students might think, wait, I can answer this question right now. After 24 seconds is over about here, I think that's going to be about 8 degrees or maybe 9 degrees. Well, that student is earning about 1 out of 27 marks if this is a task question on the final exam for this course. And an educated guess is not worth nothing. It's just that the value of that is to compare it to the answer you get when you do calculations and to use it as a verification. You want to make sure that your answer that you get with the calculations makes sense. And it does make sense that you should end up with a small positive temperature. But right now we can't work with the straight line. We're going to work with this first curve. And I don't know for sure if it's quadratic or exponential or linear. I can guess at that, but a guess again isn't worth very much. I'm going to do my tests. Starting with constant difference, negative 0.25 minus 0 equals negative 0.25. Then negative 1 minus negative 0.25 equals negative 0.75. Already I see that I'm failing the constant difference test, but I'll keep going. Negative 2.25 minus negative 1 equals negative 1.25. And finally, negative 4 minus negative 2.25 equals negative 1.75. So I failed the constant difference test, and I know it's not linear. So I say so. Now I'm going to do the second difference test to see if it's quadratic. And for that I'm using the answers from the first difference. Negative 0.75 minus negative 0.25 equals negative 0.5. Negative 1.25 minus negative 0.75 equals negative 0.5. I'm getting a constant second difference. Negative 1.75 minus negative 1.25 equals negative 0.5. So I know that this is quadratic. And I don't have to do the test for exponential. But if I want, I can do it. It's another way of just making sure that you believe in the function that you found. Okay, so now the next step is to find the equation of the quadratic. I know for this course, it has to be an equation in the form of y equals ax squared. If you're studying a more advanced quadratic math course, then you have other forms and different things can happen in the questions. But in the course I'm preparing this video for, that's the only form of the quadratic the student is responsible for. So what we're doing to find the equation is simply plugging in one of our points to see what the a is. I want to use a point that's easy to work with, so I'm going to use 4, negative 4. Negative 4 equals a times 4 squared, which is 16a. And then if I divide both sides by 16, a is equal to negative 0.25. My equation is y equals negative 0.25 x squared, or if I wish, negative 1/4 x squared. Now I have enough information to find out what happens here. Remember in the question that we were told the student added something after 6 seconds, so we know the x coordinate of this point, where the first reaction ended and the second one started. So we need to know the y coordinate. Y is going to be equal to negative 0.25 times 6 squared. 6 squared, of course, is 36. Now this would be easier if this was in a fraction. Y equals negative 1/4 times 36. I can see easily y is going to be equal to negative 9. Now, of course, if you use your calculator, or if you're comfortable with decimals, you can still get this answer. So we have the point 6, negative 9 right here. I'm going to write it on the graph. That means we now know 2 points for this straight line. 6, negative 9, and 18, 0. Because the 0 for that linear was given on the graph. So I'm going to do the slope formula next, using those 2 points. 0 minus negative 9 over 18 minus 6 is equal to positive 9 over 12, or 3/4. My equation is going to be y equals 3/4 x plus b. I need to know the b, the y-intercept, which I can see is going to be down here. It's going to be a negative number. I'll plug in one of the points that I know. I'm going to use 18, 0 again. So 0 equals 3/4 times 18 plus b. 3/4 of 18 is 13.5. So b is equal to negative 13.5. I know my linear equation. It's y equals 3, well, I'll do it all in decimal. Y equals 0.75 x minus 13.5. There's only one thing left to do. They asked what would be the temperature after 24 seconds. So I'm going to plug x equals 24 into this equation. Not easy to write on the very bottom of this. 0.75 times 24 is going to be 18. So it's 18 minus 13.5, which is 4.5. And the unit of measure is going to be degrees Celsius. So what we have here is a task question that is asking us, without telling us which techniques to use, to answer this question and justify it. And in order to justify it, I have been put in a position where I have to go through all of these steps. The first thing that I do is my tests to see what type of function is happening at the beginning of this graph. Once I've figured out it's quadratic, I do the technique of finding the equation in y equals ax squared form. Then I have to plug x equals 6 into that. This is actually a spot in the process where a lot of my students seem to struggle. They had all the information necessary to realize they needed to plug x equals 6 into the quadratic function in order to get this negative 9 so they could continue. But some students will be tempted to try and read that negative 9 off of the graph. Reading it off the graph is not useless. Just like answering the final question by looking at the trend that's showing in the graph is not useless, but it is much more powerful and convincing and worth more marks if you actually use the math that you can justify to prove what the y coordinate of that point is instead of just guessing it from a graph. After that, we're able to use the slope formula. We're into some straight lines math, find the equation of the straight line, plug in the 24 that was given in the question in order to get our final answer. And of course, don't forget your unit of measure. That is today's Daily Dose of Math. Please like, subscribe, and share.